Hi, welcome to my channel. So now I'm going to present about optical communications, which is prescribed for 4th B.Tech second semester ECE students. And here I mentioned as per JNTU Kakinada, but the syllabus is going to be covered for JNTU Hyderabad and JNTU Ananthapur curriculum also. And let me introduce myself. I'm S.V. Ravi Kumar, pursuing PhD from NIT Andhra Pradesh, and I have qualified assistant professor UGC for 2 times, and now working as assistant professor in the department of ECE, and I have total teaching experience of 15 years. So what are the course outlines I'm going to cover in this series of video lectures for optical communication? In the first, as per the syllabus, the first unit is going to be covered on the overview of optical fiber communication. So overview means here what is the historical development and what are the basics historical development of optical communication and optical fiber communication. In some textbooks they are going to mention as optical fiber communication, or simply I can take this as optical communication. And in the overview of optical fiber communications, we will start with historical development of optical communications, optical fibers, and basics of light. Light means what is refraction, what is reflection, and ray theory, Snell's law, like this. All the fundamentals what you already know from intermediate physics. So we are going to recollect all the topics in the first unit of optical communication. And after that, in the second unit, what are different fiber materials we are going to use? So fiber materials means like a glass, and again some classifications in the glass materials we use it to fabricate optical fibers. So optical fibers performance is completely depends on the material what you are using to manufacture that optical fiber. So here we are going to discuss about what are different types of materials used to manufacture fiber cables. At the same time, what type of distortion is going to be observed in the optical fibers, and attenuation, absorption, and scattering and bonding losses, core and cladding losses, like this. And what is the information capacity of the optical fiber? All the things are going to be discussed under this title, signal distortion in optical fibers. And after that, types of dispersion. This is based on signal propagation in the optical fiber and what type of dispersions are going to be observed in the optical cable, like material dispersion, waveguide dispersion, polarization mode dispersion, like that. We have different types of dispersions, and we need to discuss about all the dispersion. And at the same time, pulse broadening effect in the gray index fibers and single mode fibers we need to discuss, so with some example problems. And coming to unit 3, in this unit 3, which is very nice and very easy in the examination point of view, and direct concepts we are going to discuss here: optical fiber connectors, and what are different types of connectors to connect to two optical fibers. So when you take simple twisted wire or normal connecting wires, you can just use twisting the wires and you can connect easily. But you can't use that type of procedures in the optical fiber connection process. So we have specified connectors and specified connecting procedures, and if you want to cut the fiber, we have different types of techniques, fiber splicing methods, and how to align the fibers to connect the two fibers or multi fibers. So we need to take fiber alignments, and what are different types of losses between the two fibers when you joint. Even you provide a connector, you can have some losses. So we need to discuss about joint losses and fiber alignment losses also. Okay. And in the next unit, optical sources and optical detectors, which are very important in the total subject. So optical sources means basically, you know already, laser is one of the source, and at the same time light emitting diode LED. So LED and lasers are used as optical sources. Now in this unit we need to discuss about complete structure of the LED and lasers and structural operation, how it is manufactured, and different properties of the LEDs and lasers. Okay, and so when you take optical source at the transmitting side, you need to take optical detectors at a receiver, and optical detector is also a diode type. Optical diodes we are going to use, but the diodes are pin diode and avalanche photodiode. So these are the diodes which are used as optical detectors. So we have different types of diodes. We will discuss different types of detectors, but we are going to use pin diode and avalanche photodiode only. We will take comparison analysis also in the coming videos. And in the next 5th unit, source to fiber power launching. So coming to unit 5, so where we are taking source to fiber power launching and optical receiver operation. The two are completely different topics. Source to fiber launching. When you are designing one optical fiber link, you must consider how to launch the generated power from the source into the optical fiber cable which is connected to it. So in this process you need to know about radiation pattern of the source, how the power is going to be connected to optical cable, and what are different parameters are going to affect while source to fiber launching. And in the next topic, optical receiver operation, and in this optical receiver operation we are going to use complete optical receiver block diagram and how it is going to operate, and how what are different types of errors we are going to have. So sources of errors and how to calculate the errors also be discussed. And finally, optical system design in the last unit. So if you want to design an optical communication system, so what is the procedure you need to follow? So we have some link budget, rise time budget. So like this, we need to discuss about these budgets to understand the optical system design concepts. Okay. So for this, the main objective of the course is here the properties of optical fiber we need to know, and materials with their properties and losses to discuss, and the principles of single and multimode optical fibers and their characteristics to be discussed, and working of semiconductor layers and differentiating different direct modulation and external photoelectric electro-optic modulation, and analyzing the LED and laser and pin diode operations and circuits structures, and analyzing and designing the optical communication system. And the course outcomes are to learn the basic elements of optical fiber transmission link, fiber modes and configurations and structures, to know different fiber materials, losses and signal distortions, to understand different connectors, fiber splicing techniques and fiber alignment techniques, and to learn the various optical sources, materials and optical detectors, to learn sources to fiber power launching and error calculation, and design a fiber optical link based on budgets. So they are the course outcomes expecting, and the textbooks to be followed: Optical Fiber Communication, written by Gerd Kaiser, 3rd edition. So most probably 3rd edition is not available, so you can prefer 4th edition also. And Optical Fiber Communication is John M. Senior. So this is the 2nd edition, and this is useful for the first 2 units, the basics and the dispersion mechanisms and distortion losses. And for all the remaining topics, you can follow Optical Fiber Communications by Gerd Kaiser. Thank you.